Good afternoon. Welcome to the Trulaske Business Insider Series. My name is Balaji Rajagopalan. I'm the Dean of the Trulaske College of Business, and I'm very delighted to welcome all of you to the Trulaske Business Insider event today. The topic, Talk About a Revolution, How AI is Disrupting Marketing, featuring two of our outstanding faculty members, will give you insights. I hope all of you will take away some important lessons back to work, back for discussion with your colleagues and beyond. It is my distinct pleasure to introduce two experts in the area, Dr. Shyam Niladri and Dr. Michael Thomas. Dr. Shyam Niladri is the founder and first director of the college's Center for Sales and Customer Development. His teaching and research areas of interest include artificial intelligence and machine learning applications in marketing and sales. He also conducts research in the areas of product customization, product co-creation, and Salesforce management. He is the author of the book, Machine Learning and Artificial Intelligence for Marketing and Sales, essential reference for practitioners and data scientists. Joining him is Dr. Michael Thomas, who will be joining our faculty in fall 2024. Dr. Michael Thomas received his PhD from the University of Chicago, and his research interests include advertising and its effect on health-related behavior. He comes to us from the National University of Singapore, where he is an assistant professor. Prior to that, he was at Santa Clara University. Please join me in giving a warm welcome to Dr. Shyam Niladri and Dr. Michael Thomas. Dr. Shyam, please take it away.
Thank you, Dean Rajgopalan. Welcome all to the webinar on AI in marketing. First of all, thank you all participants for taking time off from your busy schedules to be part of this webinar. Thanks to the Advancement Office at the Trulaske College of Business for organizing the webinar and for giving us the opportunity to speak. As Dean Rajgopalan said, my name is Niladri Shyam, and I'm going to be joined by Professor Michael Thomas in this webinar. I would like to invite Michael to first start us off with this webinar topic. Michael?
Great, thank you for the introduction. Let me pull up my slides here. So it's a pleasure to be here with you all and share some of these, I think, very interesting topic of AI in marketing, especially in recent years. As the others mentioned, I have taught at National University of Singapore, and there I developed and taught a course called AI in Marketing that was relatively technical. We really started to get our hands dirty with the data and kind of modern algorithms for making predictions. I promise we won't do any of that today, but I do want to start us off with a few high-level ideas that I think are important for kind of setting the stage for thinking about AI today and in the marketplace. And then, of course, I'll hand it over to Dr. Shyam, who will take us into a deeper dive into some of the more recent developments, especially related to ChatGPT, which, of course, is a very exciting area. I'd like to start off by talking a little bit about how modern AI works. And my goal is to give you some intuitive understanding for it and hopefully try and simplify it. So perhaps it doesn't appear so mysterious. I think it really is remarkable, the things that AI is doing these days. But I think it is also, while the details are often very complex, I think it's very possible to understand kind of essentially what these methods are doing. And I'm going to claim that most of these methods, not all of them, but many of them, can be understood simply as prediction tools. And prediction is something, to some degree, I think we're all familiar with. So let me go through a simple example that's probably familiar to many of you to just kind of set the stage for what I mean by making predictions. So imagine you're forecasting sales. This is something often the marketing department is responsible for. And if you're going to forecast sales, you might look at past data that you have and use that to make a projection about what sales will be, let's say, in the upcoming Q2. So let's say we have a few pieces of information to rely on. First, we know that sales typically grow between Q1 and Q2 by about 3%. Historically, that's what we typically see. However, we saw that in the previous quarter, moving from Q4 to Q1, the growth there was actually below what we typically see on average. Additionally, when we look at the growth in the overall economy over the last quarter, we're also seeing sort of below average growth. So we might take these three pieces of information and put them together and say, I'm going to wave my hands here and say, let's say our projection for Q3 growth is not going to be the full 3% we usually see, but maybe it's going to be more like 1.5%. Okay. This is a forecasting or a prediction exercise. And I've sort of waved my hands at how we did it, although that's not a terribly unreasonable thing to do. But let's look a little bit more closely at what we did at each of these steps. We took three pieces of data that we have about the past: historical growth in Q1, the more recent growth in Q4 to Q1, and then the overall economy's growth. And we put those pieces of information together, all that information that we have, in order to predict something that we don't know about, which is the Q2 growth. That's essentially what I mean by a prediction. Now, of course, you can take a more advanced approach to this. You might, especially in your college years, you might have taken some data, put it into a spreadsheet. You might have had maybe the last 20 quarters of growth numbers. You could have put all of that into Excel, along with another column that shows the growth of the economy, maybe run a linear regression and estimate a model that would allow you to make the prediction that we did here sort of automatically, mathematically. That would be a more advanced approach to making a prediction. And I'm going to argue that what most of machine learning does is essentially the same thing, just at a higher level. So what's different about what we're seeing in machine learning? Well, in our example here, we had three pieces of information that we used to make a prediction. When modern AI tools are used, often we have thousands of thousands of different variables that allow us to make predictions. Additionally, in the example that I talked through, we only had, let's say, 20 quarters of growth in order to learn about the relationship between past growth and upcoming growth. In modern applications of machine learning, often we have millions or billions of observations. So just simply the scale of the data is much different. The third difference is the model that we use to make the prediction. In my example, I took a couple of approaches. One was I just sort of waved my hands. I kind of looked at the number and made a guesstimate about what the growth was. I also described a procedure where we put numbers into Excel and ran a regression. Modern machine learning is essentially doing the same thing, except the models are more complicated. For the last 2 decades, statisticians have made huge advances in developing fairly sophisticated models that do a really good job making these types of predictions. But essentially, the basic idea is the same. We have some pieces of information that we know about, that we can observe. We're going to put them all together in order to do a good job making a prediction about something that we don't know about, but we would like to know about. So, given this setup and this claim that essentially what most of these tools are doing is prediction, how can we start to make sense of some of these extraordinary advances that we're seeing recently, such as driverless cars or ChatGPT? How do these fit into my model of these things simply being predictions? Consider driverless cars for a minute. Driverless car has a lot of measurement devices. Usually has multiple cameras that are scanning around it, often has LiDAR or radar, various ways of collecting information or data about its immediate surroundings. That's all information that can be used to inform the car what it should do at any given moment. The cars typically also have a lot of historical data in which they have made observations about things that it's seen in the camera, things that it's seen with the LiDAR, and it's seen what humans have actually done, given all of that data. So these driverless cars are taking all of this information that it's seen in the past, and essentially it's going to try and make a prediction about what would a human want to do given all of the information that I'm seeing. How it learns about that is mostly by seeing what humans have actually done in the past. Usually humans, when they're driving, do what they intend to do. Sometimes they don't do what they intended to do, and we can make corrections for that. But at the end of the day, what the driverless car is doing is saying, here's a bunch of information that I have. Let me predict what a human would do. That's essentially it. Now, the prediction is a little more complicated than say, forecasting sales, because it involves turning left, turning right, accelerating, decelerating, et cetera. But the idea is essentially the same. Same idea with ChatGPT. ChatGPT has ingested an enormous amount of information, basically the entire internet, in order to be able to function with language. It also, key input is your query that you might type into ChatGPT. Give me examples in which such and such happened. And ChatGPT is going to take all of that information that it knows, and it's going to make a very, very sophisticated prediction about what is the output that a human would like to see. Okay. So again, I'm hoping to just help peek behind the curtain here as to what's going on and how all of this, these seemingly magic methods work. And I think the takeaway message is they are essentially making predictions. The other high-level point I want to highlight is the economic implications of AI. There's certainly a lot of talk about it in the last, especially since the introduction of ChatGPT. Some of that's hype and just excitement. It is very exciting technology. We also see very large companies making huge investments in this area, and might raise the question: is that misguided? Do they know something I don't, et cetera? And I think an important part of understanding what we're seeing these days, especially from the larger companies, is there are winner-take-all dynamics associated with AI, just simply because of the way it works. This applies mostly for businesses where their key output is predictions. So if you're Google and you're making predictions, somebody enters a search query, you're making predictions about what they see in the search result. If you're developing driverless cars, we talked about making predictions about what a human would want the car to do in any given situation. If your core product offering is some type of prediction, these dynamics become pretty important. And I think that's why we see much of the urgency and investment that we're seeing from large companies these days, is because they're concerned about being left out. So how do these winner-take-all dynamics work? The idea is the following. The key insight is that AI works better if you have more data. The more training data you have, the more past data you can observe, the better these models perform. And so if you can make predictions, and that is your core product offering, you're going to tend to attract more customers. If you attract more customers, you get to collect their data, which is going to allow you to improve your product even further. That's what I mean by this positive feedback loop, is if you have the best product, you get the best customers, which means you get to improve your product in a way that's very hard to compete with. I think Google, for the last 20 years, is a helpful example of this. Clearly, there's a lot of other things that went into Google's success, but I think these dynamics are an important part of their success story. So 20 years ago or so, Google became the dominant search platform. Once they became the dominant search platform, that means everybody was going to Google because they gave the best search results. Because Google gives the best search results, they get data on what people actually wanted to click on when they entered a given search query, which means they can continue to refine their algorithm and offer a better product. Other companies, Microsoft, for example, would much like to get into this space, but even with all of Microsoft's resources, they simply just cannot compete with Google, I think to a large part because they don't have the same body of data. And there's just no way to replace that. And so as we're seeing these new changes, these new advances in AI technology, there's a lot of concern from companies that they're going to be left behind. Everybody wants to be the monopolist of whatever new industries are going to be created by this technology. And there's an understanding that they're going to tend to generate monopolies because of the dynamics I described here. On the other hand, if you're in a business, making predictions is not your core product offering, this may be less of a concern, and there may be very well be less urgency. I think it's probably the case that for a lot of companies, new AI technology can help improve some of your productivity, but it's not the core part of what you're offering to your customers. In those cases, I tend to think there's less urgency. Much of the technology that we're seeing now is new. A lot of businesses are sort of fumbling and experimenting with trying to discover how to use it effectively. And if that's not a core part of your business, in cases it might make sense to just wait and see how this evolves. And once there's kind of more refined solutions you can integrate into your business, go ahead and do so. Let me go through a few examples, kind of standard examples for marketing, which are essential to making predictions. And these examples predate, I think in all cases, predate machine learning, but machine learning and modern AI has certainly improved the quality of these applications. So let's talk about them briefly. These are things that we talked through in my class a lot, so I think it's worth briefly talking through them. Churn management is a huge one. Typically, if your business relies on subscriptions, such as Sprint, churn is very costly to you. You want to retain your customers for as long as possible. Because they are your customers, you typically have a lot of data on them. Hopefully you've been storing customer data and your interactions with the customers over time. This gives you a long history of interactions with customers, and that is rich data that you can use to make high quality predictions and predict who is likely to churn at any given point in time. You can think about possibly intervening and trying to prevent that churn, offering them a special coupon, reminding them that they're a valued customer, what have you. Related applications of these types of technologies are predicting who prospective customers might be. So Harley Davidson has reported big success with this, and Professor Sham's going to take us on a deeper dive into how they did that. It can also be used to predict who you should give upgrades to. So I think ever since the first hotel was built in the middle of the Nevada desert, casinos have been giving comps to big rollers. I mean, it's a great strategy. In the early days, those decisions were probably made by individuals and humans who knew these people, kind of got some information about their backgrounds, kind of assessed that this is what likely to be a high roller. These days, Caesar's Palace is using machine learning to make these types of decisions about who the upgrades should go to. Finally, and this is actually a more recent development because it's more difficult, these tools can be used to make product recommendations to individuals. This is especially important if you have a very large number of products that you sell. So Netflix is an example of this. They've got thousands of movies and TV shows to watch. Sephora is a company that sells makeup. It's not something I buy, but I understand there's a lot of different colors and flavors to makeup. And so this can be a very useful tool to customers to help them find the product that is a good match for them. This is technically a bit harder problem than the ones I talked about before, but it's one that the magnitude of the data that we have these days and the tools we have are able to address. So obviously Netflix has had huge success with this. They also have an astonishing amount of data. Again, Professor Sham's going to take us into a deeper dive into kind of the more recent developments with ChatGPT. I'm just going to provide a couple of high-level comments. First is much of what we're seeing these days, much of the hype and the discussion, much of it is really just window dressing. So an example that's somewhat close to home to me as a frequent Spotify user is the AI disc jockey they released in the last year or so. Spotify has been giving music recommendations since forever, but it's just in the last year or so, they introduced the AI disc jockey, which gives you essentially the same recommendations that you got before, but now there's computer-generated chit chat in between in the style of a disc jockey. Does this add a lot of new value to Spotify customers? Well, not to me personally, maybe to others, but it doesn't seem like an essential step forward in sort of their offering. Chatbots have been around for a while, and this is a place where I think we're going to see huge advances with ChatGPT. And I think Professor Sham will go into that in much more detail. We're also very recently starting to see AI tools that are developed to help high-skilled labor. So we're seeing tools that are going to help lawyers and help them to search large number of documents they've traditionally had to read. In the past, they get junior lawyers and they just tell them to read through thousands and thousands of documents to look for instances that might help their case. As AI technology is increasingly able to handle language and sort of understand language, they're going to be able to search through the documents automatically. We're already able to search for specific words, but increasingly we're going to be able to search documents for concepts. And that's of enormous value to lawyers especially. We're also very recently starting to see AI technology that helps software developers write code. So I use GitHub. They've recently offered the Copilot service where for an extra $10 or $20 a month, you have an AI chat tool where you can say, hey, write some code for me that does such and such. GitHub claims it improves productivity. Others disagree. But I think in the coming years, this is going to be an essential part of software developers' toolkit, which is I think exciting. All right, I'm going to wrap up here with one last thought. We are still in a new phase of AI's development, and that means a lot of us are still experimenting with how to use it. And Instacart is certainly one of those examples. Instacart is a way to kind of order your groceries online. And in a way to try and encourage people to buy more, they suggest recipes. They provide recipes and say, hey, you could, if you bought these ingredients, you could put this together at home. And they've used generative AI to produce photos of what you could make with the recipes. Unfortunately, some of their photos went awry, and they have since quietly turned off this service. But just to show you how some of these experiments can go wrong, Instacart suggested you could make grilled hot dogs and provided this picture of what a grilled hot dog might look like. It does have a hot dog on top and a bun on the bottom. In between, there's a third layer, which looks something like a cross between a bun and a hot dog, again, produced by AI. Some might find these chocolate chips desirable. Others might find these very large chocolate chips unappetizing, but this was also generated by AI. And finally, Instacart suggested, hey, you could make salted chocolate chip pretzels at home. And unfortunately, the machine produced horribly misshapen pretzels. So with that, I'll stop and hand it over to Professor Shah. Thanks.
Now, let me just try to put some structure on what is happening when AI and digitalization more generally is disrupting marketing. So it would be kind of useful, I think, to look at marketing in terms of the tactical elements and the strategic elements of marketing. And most of us are kind of familiar with those. So for the tactical elements of marketing, we can borrow the framework of the 4 Ps: product, price, place, and promotion. And for the strategic elements of marketing, we can borrow the framework of STP: segmentation, targeting, and positioning. Those are higher level, but I went with the tactical levels first because a lot of AI disruption, digital disruption has been happening more at the tactical level, a little less at the strategic level. And it's also easier to talk more tangibly about the tactical level. So that's what you see down the rows. Now, for each of the tactical and strategic elements of marketing, we can discern how AI is disrupting the lower order mechanical tasks or the higher order analytical and relational tasks. So for instance, for product, And we don't really need to look at very deeply at the small print. I needed to fit all of this in this table. But let's look at product, and one product that we are all familiar with, and which is having a lot of advancement because of ChatGPT and generative AI and large language models, is chatbots. So if you look at the very first row for product, there is for the lower order mechanical tasks, there were chatbots even before generative AI really came onto the scene. Now, those were what's called rule-based chatbots. And I'm going to talk a little bit more about that a little later. So later on, over the last maybe 5-6 years, chatbot technology has really been revolutionized by natural language processing and generative AI. So that's like the NLP-based conversational AI chatbots. There's Claude AI, there's BotPress, there's HubSpot, which has gotten a lot of benefit and a lot of success using generative AI chatbots. So that just gives you the contrast of, and this is what Professor Thomas was saying, that some of AI seems like old wine in new bottles, but I'd like to extend the metaphor a little bit more. I mean, it is to some extent old wine in new bottles, but the newness of the bottles kind of enriches the experience itself. So, and what does it mean for chatbots? I'll take an example of chatbots, and I'll go through that in a little bit more detail later on, right? Contrasting pre-generative AI and post-generative AI with chatbots. So that gives us an apples to apples comparison. Again, for, if you look at the column where you can see my cursor, there is augmented reality, virtual reality in retailing for product visualization in a customer's own space. Sephora was brought up as an example by Professor Thomas. Sephora does this very well, where they have this AR VR tool where a lady trying on makeup or maybe earrings or something like that can see what it would look like in her own space in the comfort of her own home before actually venturing out to the retail store. House is a platform that now allows people to use AR and VR for what's called building information modeling. So this is where the interior designer or the architect can kind of simulate what would it look like to have a sofa or a cabinet or something else in your home, where before doing this you'd have to kind of use your imagination to say, oh gosh, I'm going to get this sofa, but I'm not, if you're in the furniture store and you're not very sure how would it look like given my drapery, given my carpets, given the color of my walls, given the other furniture that I have. But now you can all simulate it out on your cell phone. So that's a little bit of what's called building information modeling. And also it's happening in the B2B space of construction. Personalized service is another way where higher order analytical and relational task-based AI is disrupting product design. How does AI come into personalized service? Well, what it does is it essentially enables the machine to really uncover people's preferences. Now, in marketing, we had a tool which would do preferences, which would understand people's needs and preferences even before AI became quite the rage. And that was what's called conjoint analysis. Some of you may have heard about it. What did AI do? Now, the traditional conjoint analysis has been replaced by machine learning-based conjoint analysis. And essentially what it does is it removes all the restrictive assumptions of the traditional conjoint analysis, right? So the traditional conjoint analysis might have made some assumptions of linearity and this and that, but the new method actually doesn't make those restrictive assumptions. And also on top of that, it can use data which is called roughly unstructured data, text, video, voice, things like that, right? Again, old wine in new bottles perhaps, but the newness of the bottles enhances the experience. Professor Thomas talked about recommendation engines. That's about the product also, suggesting products. And this is what the feature that we have in Amazon. When we buy a book, and then immediately we pop up, we see the message which said, people who purchased this book in the past have also purchased this other book. That's a recommendation engine, and that uses deep learning. These days, Taylor Brands has done what is called AI-assisted branding. So they use what's called a decision tree. And what it does is it's a tree-like architecture of a model, and it uses the client. So the client approaches Taylor Brands and says, we want to develop our logo, but we don't have the deep pockets of a Procter & Gamble. Could you help us develop a logo? And then the client has to go through a sequence of multiple choice questions. And from the responses to these questions, the AI machine learns about their preferences, infers their preferences without being explicitly articulated, and it suggests these brands. Okay. So for price, what do we say for price? Now, on the lower order mechanical task for price was the very obvious automatic payment systems, PayPal, Square, etc. That's a lower order task. That is just a functional logistical element of enable people to pay. But on the other hand, for pricing, we have the higher order analytical and relational task that AI performs. So it does personalized pricing. So what does personalized pricing? So there is one way, a famous example in which a company did personalized pricing by using people's word of mouth on the social media to uncover, willingness to pay. And, the willingness to pay for a product is a very important ingredient of price optimization. So what the AI tool does is it scrapes the social media footprint of a person. It takes the word of mouth, and then from the word of mouth, it infers willingness to pay. And based on the willingness to pay, it recommends prices, personalized prices. There is dynamic pricing, which uses statistical machine learning, and then price negotiations, which essentially depends on understanding, capturing, and analyzing live interactions, real-time communication, and sentiments. Again, AI is really good at doing that. Anything real-time, anything when the data is coming in as a live stream, whereas the typical traditional methods were not able to do it. So much of it is, yes, the idea might have been there in the traditional sense as well, but what AI does, it puts it on steroids and actually uses that in a much better way to make, as Professor Thomas was saying, many of these things are prediction machines, but the prediction can be done in real time. It can be done much more powerfully, much more accurately, and most importantly, it can leverage the richness of unstructured data where the traditional methods, Excel, for instance, we understand Excel as a spreadsheet with rows and columns. Well, how do you incorporate video data? How do you incorporate audio data? How do you do all of that? So that's what AI can actually do over and above the earlier things. We can look at place. Amazon uses predictive analytics for anticipatory shipping. Natural language processing based personal shopping assistants have become ubiquitous. Macy's On Call is a digital personal assistant, mobile personal assistant, which enables a person to locate products in the store and also gives them live updates about what are the deals available. So in the time remaining before we break for Q&A, let me do a little bit of a deepish dive, I would add, because one of the things I wanted to give you a sense of is, what do we mean by generative AI, and how does it help some of the things that we were doing previously? Maybe AI was doing it, what it was not being done in the manner that is being done right now. So let's look at chatbots, for instance, which, every company nowadays has some sort of a chatbot situation. The traditional chatbots were either rule-based or retrieval-based. Now, quickly speaking, what was a rule-based chatbot? It used what's called pattern matching. Now, pattern matching, the key to understand pattern matching was the modeler, the analyst, had to hand code and manually give all the rules of grammar for recognizing the patterns. Now that became a nightmare because English grammar, for that matter, grammar in any language is extremely rich, and it has tons and tons of exceptions. What do we mean by exceptions? So, for instance, let's take the word jump. A child jumped on the trampoline. Well, you can use jump as saying someone jumped to the head of the queue. On the other hand, jump could also say, I watched a really scary movie and I literally jumped out of my skin. So with the traditional chatbot, all the connotations and the richness and the context of jump would have to be manually hand coded into your chatbot. And you can imagine that became a nightmare. So what happened was, it was very good only for doing very, very simple tasks, and it would not be able to take a whole series of multiple turn conversations. It could take only single turn conversations where only the last line of the other person was being responded to by the chatbot, and the history of the context was completely lost, right? In between, there is something called retrieval-based chatbots, where the knowledge base of the chatbot was not entirely hand-coded, but it uses API. It used API to draw from the web. But what it could not do, it could not generate its responses based on its own intelligence. Now, this is what generative AI does. What generative AI does, it uses not only the current user's message, but uses the whole sequence of the historical sequence of previous messages. It's much more human-like. We don't only respond to the last sentence uttered by someone we are talking to. We kind of remember what all the things that they've been saying for the last 5-10 minutes, and we can respond appropriately. What these chatbots do, it uses machine learning and deep learning techniques. Specifically, they use natural language processing and natural language understanding. And the foundational models are large language models and what's called transformers. Now, just to give you, I mean, I don't want to give you a very deep dive because at the end of the day, it's a webinar, but a little bit more, opening the black box just a little bit more on generative AI. What does it bring to the table over and above what I said was this very pattern matching kind of a situation for chatbots? What it does is it does pattern recognition. And the way it does pattern recognition, again, we're going to hear the word, it uses predictive analytics, machine learning-based predictive analytics to do pattern recognition. Pattern recognition is different than pattern matching, which is much more human-coded. So it has two basic features or two components or modules. One is natural language processing, which is an area that gives computers the ability to understand text and spoken words in much the same way that human beings can. And then there is also natural language understanding. Now, that is where it infers a person's intent. And intent detection is formulated as a sentence classification task, which again is basically a prediction. In which case now the difference is you're not predicting a sales or you're not predicting demand, but what you're predicting is the class that an intent would belong to. So for instance, what is the weather in Greece? The intent is you're trying to learn the weather. You're not making a reservation. You're not looking at a menu. You're trying to learn the weather. And what's the entity for which you're trying to learn the weather? It's Greece. So it does this kind of entity recognition and intent recognition. And these recognition tasks, again, are basically machine learning-based prediction tasks. I'm kind of going to wrap up. So what is the richness of NLU? I'll just give you a couple of examples. Why is this kind of a very complex task? And you can imagine that it requires a fairly sophisticated machinery and a model behind NLU, behind what's called the large language models to understand natural language. Just look at, two sentences, right? Bill Clinton lives in New York, a few miles away from an IBM building. So the model needs to recognize that New York is a place and IBM is an organization. That's what's called automatic entity recognition, named entity recognition. So the named entities are personal, a person, place, organization, etc., right? But it's got layers and layers of complexity. Look at the second sentence. I like New York and I love reading the New York Times. So now the AI module needs to recognize that the first New York is a place and the second one is the name of a newspaper. So it's a non-trivial task, okay? So what modern chatbots do over and above the earlier rule-based chatbots is it kind of gives the machine the ability to talk to another human being much like a human being would talk based on NLP, natural language processing, and NLU. And the most important module that it depends on is the NLU module, which basically enables the machine to understand human beings just like human beings would understand each other. Okay. Now, there's a lot of evidence that chatbots are useful. The question is, is there any empirical evidence that they actually work? Do they increase sales? Do they increase upsell? Do they increase cross-sell? Now, for many of these things, empirical evidence is very hard to come by. But for chatbots, there is some limited empirical evidence that there was at least one study that I have come across, which says there's hard data, which says, the willingness to trade up to a more costly car rental option depends on the type of bot that you're using. And if you see the three circles, your choice upsell option was, in that study at least, it's one study, but it's some data point more than in many other things. It's 29% for if you just have a website. If you have a neutral chatbot, which is not personalized, a neutral chatbot, it's 49%, the choice upsell option. And if you have a personalized chatbot, it's actually 55%. So there is some limited evidence that, yes, there is empirical evidence that chatbots actually work, they help, and they can actually benefit people. So I'm going to stop here now. And Michael and I would like to just engage you guys in a conversation, and we can open it up through some kind of a Q&A. All right. What impact do you see this having on the types of jobs, how marketing jobs will shift focus? I'm going to add my 2 cents. I believe the job impact is going to be happening on what I said, the mechanical jobs, which are easily automated. Those are jobs where I said, the rule-based chatbot, that's the kind of job it did. PayPal, taking automatic order taking, automatic payment processing. So lower order mechanical jobs, which are easily automated, are going to basically, I'm not going to say disappear, but they're going to be reduced much more in the economy. Higher order jobs, which need this analytical and relational focus, those are going to be much more difficult to give, to completely offload to AI. What we're going to see is this human machine collaboration, that instead of a physician or instead of a marketer, let's say, doing the job of campaign strategy themselves, they can use the AI automatic tool to what's called algorithmic campaign planning, where the marketer gets a steroidal boost from using the AI to increase their own productivity. So it's not going to replace the marketer, but it's going to increase their productivity. But that's going to be for the higher order tasks, not so much for the lower order tasks. Michael, would you like to add something?
No, I think that was good. I was thinking about the next question.
All right, you can take that.
Sure. So the question is, what would you foresee as an application for AI in a B2B manufacturing process where volume is low? So you're right on to be concerned about situations where volume is low or number of customers low. I've dabbled in B2B a little bit myself, and especially in businesses where you have 4 customers representing 90% of your business. A lot of these tools are going to be more difficult to use. I think that's correct. There may still be opportunities. So things like demand prediction may be an opportunity. Inventory management could be an opportunity. But I think you're right to keep in mind that these tools are going to work better where there's a lot of data. And certainly, I mean, this is outside of kind of the business, but if you have a manufacturing process, those are often very data-rich environments. So if you're trying to detect defects, that sort of thing, there's a lot of opportunities there.
Okay, there's also a question about, I think that Matthew K is essentially clarified his question by saying, in other words, not a huge amount of customers. That's B2B basically in a long sales process. There's a question about, are there organizations in which the use of predictive methods are evaluated when used? That is, how are these methods held accountable? Let me actually, I love this question. And, for a long time, I got into this AI in marketing at least 8-9 years ago. For a long time, this was a question I had, and only now we are starting to see some empirical evidence surfacing about the actual efficacy of these tools in the bottom line. I mean, it's one thing to just do it. The other thing is to say, did it increase my revenue or my profit or my sales? And if you don't mind, let me actually, I had started to do the share when we broke for questions. Let me go back to my share again. I love this question, and let me quickly share something. I'm going to take an example of augmented reality, virtual reality in marketing and sales. Okay, we kind of understand augmented reality. It's a mental environment created by inserting digital information on a person's view of the real world. You know, for instance, you have the city of Vienna, and you have this person, and this is the tourism app, and you have this person going around the city. They are seeing exactly on their camera what the city looks like when they're walking in real time, but also it's being enhanced by digital images about, do you want to see a museum? Do you want to see this? Do you want to see that? Do you want to go to a hotel? Do you want to find an ATM? So it maps, it superimposes digital content on the person's view of the real world. That's AR, right? So there is one, I'm bringing up this whole thing of, so what? What do we get anything out of it? So here's my slide, and I didn't go through it because I wanted to respond to questions, but it's a great segue to this slide. Can AR really drive higher sales? So there is a recent article at the top marketing journal, the Journal of Marketing, where it took from Southeast Asia. There was a cosmetics retailer that introduced AI in their thing. So there was a CNN article which basically posed exactly the same question that the anonymous person asked, is like, virtual lipstick and smoky eyeshadows are popular in apps, but are they translating to more makeup sales? Hard data isn't easy to come by. That's 2019. And then in 2022, there was this article which got data from this cosmetics retailer. It's a cosmetics company which introduced the AR feature for some eye categories. The AR feature was available only for eyeshadows and eyeliners, but not for mascaras and eye palettes. The AR feature was available only on the mobile app of this thing. The goal was to see if the introduction of AR has really increased sales or not. And like I said, this came up in the premier journal in our field, Journal of Marketing. So it has to go through a very rigorous process of double-blind reviews. You have to provide a lot of evidence and the data. And basically what they found is, yes, the result is, cutting to the chase, there is a positive impact of AI introduction on actual sales. So, so again, you know, there is some evidence coming up. It keeps on coming up more and more. Now we're going to see it. It took a while. It took about maybe 5, 10, 15 years for companies to actually have the stream of data that could be mined to actually say, can we do a before and an after kosher analysis to say, once we compare the before to the after, do we actually see an uptick in sales, increased profitability? Like I said, I showed you a little bit of an example of that for chatbots and cross-selling opportunities with chatbots. There is some limited evidence. And here there's a little bit more better evidence because it got archived in a major journal of does AR really help in the retail space?
If I'll jump in on that just briefly. This is my own take. I often run experiments with businesses, and it's something I'm very excited about. It's increasingly possible these days to set up experiments because so much is done digitally, like just the cost is falling. So I'm going to get on my soapbox for a second. The value of experiments is they give you credible results that you just cannot get any other way. Even if you have data to assess something, if you haven't run an experiment, there's ways to try and make sure you get the right answer, but they're all typically flawed and you're never sure if you quite got it right. If you run in a good experiment to evaluate whether your AI implementation is working or not, you're pretty much guaranteed to get the right answer. And so I'm not saying experiments are always the right solution. They're often very expensive. I mean, they're expensive. That's the big cost. There's opportunity cost associated with them. But if it's a big decision and the cost of implementing an experiment isn't too high, why not have the certainty that it's absolutely working? So something to bear in mind, not just for assessing AI, but assessing really any marketing application. I'll stop there.
Yeah. And to add to that, this article that I mentioned that did exactly that. It ran an experiment They had a control group, they had a treatment group, and they did a before and after, both for the treatment and for the control. Treatment was the eyeliner and the eyeshadow category, which had AR, and the control was the other categories like other, I can't think of cosmetic categories right now, but the other categories which did not have this augmented reality feature. And by doing this contrast of the treatment and the control group, so they ran what's called a field experiment, and they did this difference in difference analysis to kind of establish that yes, AR did actually increase the sales. So yeah, point well taken. And experiments are expensive, but the costs are becoming less and less and less, and there are ways to do this even on a small limited scale. I think it's almost like saying, yeah, it's expensive to do that, but it's probably more expensive, quote unquote, in a metaphorical sense, not to do it and not to know if what you're doing is actually adding to your bottom line. So I see another comment. I was thinking utilizing the built-in AI in a software like Salesforce would be most likely application. So what do you have in mind, Matthew? Can you just elaborate a little bit more? Salesforce.com does have an AI module called Einstein. So what Einstein does, Einstein AI, they call it Einstein. What Einstein does, it actually helps you do the lead qualification in real time as you go down the sales process. So it takes the lead. It's almost like it basically says, when should you take a lead which was just more like a lead which wasn't qualified, and then you qualify the lead. But nowadays, lead qualification can be done in many ways. Previously, we used to have what's called BANT. Does it have the budget? Do they have the authority? Do they have the need? And is the timing appropriate? So BANT. So now what you can actually do for lead qualification is use a salesperson's social media footprint. You can look at all the things that they say on their all the social media platforms. You can mine that information to do lead qualification. You can similarly, companies also have a social media presence, and based on that and mining that information from the social media presence, you can do lead qualification in a much more kosher manner and using a much more richer data set kind of, rather than doing just the band. So Einstein is Salesforce's way of doing AI. And I think that's the first AI in CRM, if I'm not mistaken. The premier AI in CRM is Einstein right now, and it essentially does the sales process. And like you said, Matthew, it gives you a prediction of when to follow up. It gives you a propensity score of the person actually going from one stage to the next stage in the sales process. And based on that propensity score, it says, should you intervene and make the call, do the follow-up? What would increase the chances of making a person go from stage A to stage B in the sales process? And who should you follow up with? There are some people whose propensity is very high, so they're going to go from stage A to stage B, or stage 2 to stage 3, no matter what in the sales process. So maybe you don't really need to follow up with them. You need to show them the love a little bit, but you don't need to do the hard sell. There are some people whose propensity to go from stage 1 to stage 2 is very low. You don't really need to do that, or you don't need to prioritize that. There's some people whose propensity to go from stage 1 to stage 2 is kind of in the middle. Those are the people who you need to basically follow up on in order to go. You would not be able to do that if you did not have the propensity scores, which are probabilities. And again, Einstein gives you those probabilities automatically. So that's how you push an opportunity down the sales process using Einstein. It was a pleasure interacting with all of you. And thanks for giving us the opportunity to talk to you. Thank you, Professor Thomas, for sharing his time, and then everyone else for participating, and for Dean Rajgopalan to also graciously come and introduce us. Thank you all.